talking about the size of the observable part of it. James Beach writes, "In the beginning there was nothing, which exploded." Now, a lot of non-scientists like to repeat this statement, but no credible scientist has ever said this, nor believes it. So it's unfortunate that this statement is used to deride the Big Bang Theory. The Big Bang describes a series of events that happen to the universe following its existence in an extremely hot, dense state. We have a ton of evidence that the universe was once in such a state. Perhaps our understanding of this state will eventually lead to a theory of the origin of the universe. But the Big Bang Theory as it stands does not claim to explain such an origin.
The Big Bang Theory is an elegant solution that perfectly explains the expansion of the universe and the creation of all the forces in the atoms that govern the universe. But much like the TV show named after it, the Big Bang Theory works until it doesn't. There are a few fundamental issues with the Big Bang Theory that have yet to be resolved. Here's 5 of them. Issue number 1. What the hell? This is the obvious question. So there was nothing and then there was everything. So where did it all come from? Why did it expand in the first place? Science still has no idea. Issue number 2. Missing magnetic monopoles. In the first epoch of the Big Bang, known as the Grand Unification Epoch, all the forces of the universe were combined into one unified force at like trillions of degrees. When our supercomputers simulate these conditions, they predict the creation of a particle called magnetic monopoles. They're massive particles that really should be found all throughout the universe, but we've never found one. If our understanding of the beginning of the universe is correct, then these things should be everywhere, and they're not. So that's a pretty big mystery. Issue number 3, the flatness problem. Space-time in our current universe is extremely flat. It just has a very slight curve to it. But in a universe that expanded from a single point, this is theoretically impossible. The universe would have to be either completely flat or massively curved, because any deviation in curvature in the initial conditions as the universe expanded would cause it to expand in its curvature as well. But it apparently didn't. For example, if you pointed 2 lasers in the same direction with just a half a degree difference in angle, after 5 feet you probably wouldn't notice the difference at all. But after, say, 5 light years, they'd be millions of miles apart. It's that difference in initial conditions that can make a big difference down the road, and somehow in 13.7 billion years of expansion, our universe didn't do that. Issue number 4, the horizon problem. The temperature of the CMB, the leftover radiation from the Big Bang, is almost perfectly the same no matter what direction you're looking at it. So the CMB temperature here is the same as here, even though they're nearly 30 billion light years away. For something to be that uniform and smooth would require it to be able to communicate with each other. For example, if you place a hot cup of coffee on a table, the heat of the coffee would warm the table and vice versa until both were the same temperature. That's communication. But different sides of the universe are too far away for light from one side to have ever reached the other side, so energy has no way to transfer between the two, which makes communication between the two impossible. One side of the universe is like, talk to the hand. And problem number 5, the clumpiness issue. As I just said, the CMB is extremely smooth and even, but the rest of the universe is fairly clumpy. At the grandest scale, our universe is made up of clumps and filaments of galaxy clusters, leaving giant voids of nothingness like it's a giant sponge, or as many have pointed out, very similar to the cellular structure of the brain. In order to explain how such a uniform expansion could create the clumpy, brainy universe we see today, scientists have had to turn to our old friend dark matter. Only dark matter can really explain why the universe clumped together the way it did, but of course we still have no proof of dark matter, so that's kind of a problem. Now, Big Bang proponents, i.e. the vast majority of scientists, believe that these questions will be resolved with enough study over time, and you know what? I believe them.
So Jim, your best nothing is what?
Not anything. That's the theory of nothingness. I'm sorry, it's no more interesting than that. And that's why, by the way, philosophers spend very little time vexing over the concept of nothingness. It's not that complicated.
So
Yeah,
all the
although
philosophers...
hard to imagine. Once again, professional bullying on television.
Wait. So Jim, so you're saying all the philosophers who are still arguing nothing should just listen to you?
No, they don't spend. It's not a fruitful philosophical notion unless you make heavy weather of it the way Heidegger did and say it's this annihilating force that should inspire angst within our breast. I mean, that's kind of fun. Or to imagine, the world is a little sealed container of being surrounded, floating in a sea of nothingness, and a little bit of nothingness leaks in when we go into the cafe and we expect to see
Did you
Pierre
use the word
there,
angst?
and Pierre. Yeah,
Yeah, okay, I
yeah,
just
it's the
thought
Upper
I
West
just caught up
Side.
with that
It's
sentence.
It's a philosophical term.
So nothingness induces angst in us.
Yes, in me it induces jollity. We all have different temperamental reactions to it.
Rich, you seem to be pretty cool with nothing.
Look, there are a variety of forms of nothing, and different one, and they all have physical definitions, and you might not like any of them, but one is empty space, the other is no space, and the other's no space, no time, no particles, no laws, and that to me is as close as to nothing as you can get, as close as to nothing as you can get, as close as to nothing as you can get. And in fact, as I see, I don't see why people have any problems with it. Each of these lights in this room emits a photon. The photon wasn't there before it was emitted. It wasn't in the electron. It wasn't in the atom. It was created from nothing. And some people don't have a problem with that.
No, it's created
The
from
same
energy.
thing- the
Created
same
from
thing
energy.
can happen-
Lawrence, it was created from energy. And energy is not nothing. So I won't accept your photon
Well,
analog.
it could. A zero
Back up
energy-
and say something
Sorry,
else. Lawrence, it was created from energy. And energy is not nothing. So I won't accept your photon
Well,
analog.
it could. A zero
Back up
energy-
and say something
Sorry,
else.
a zero energy photon. A zero energy photon. Our universe could be like a zero energy photon, a zero energy total universe.
So your universe that's created out of nothing, where there are no laws, no space, no time, no anything, that nothing had to know to create the universe.
Well, there may have been something else there, but our universe was
now
there.
you confess. I'm just trying to
Yeah, there
understand
was
because
nothing.
so your universe that's created out of nothing, where there are no laws, no space, no time, no anything, that nothing had to know to create the universe.
Well, there may have been something else there, but our universe was
now
there.
you confess. I'm just trying to
Yeah, there
understand
was
because
nothing. Well, there may have been something else there. Well, there may have been something else there, but you
There,
don't
you're,
even
you're
agree
purporting
with
to
in-
offer
in
us an
theology.
explanation, and
What?
you're offering us no explanation. All you're saying it just is.
yeah, he's kind of doing
Yeah,
it.
all
You're
Eva.
not talking about a process that's governed by
it's-
laws, by rules, in which
we say
initial
what the
conditions
rules
you're
are
just
that
saying.
caused our universe.
Remotely persuasive definition of nothing I've heard from a physicist came from Alex Vilenkin, who said, imagine a closed spherical space-time. Imagine the surface of a ball. It's a finite space, but it doesn't have any boundaries. Now imagine the ball shrinking down to a point. Its radius goes from finite, shrinks down to 0. So now you have a closed space-time of 0 radius. This was Alex Vilenkin's definition of nothingness. And he did some quantum mechanical computations and showed that given a closed space-time of 0 radius, there's a finite probability that a little nugget of false vacuum will spontaneously appear, will nucleate out of that, and that, by the miracle of inflation, will evolve into the world we see around us. And I think that's a really nice story.
But-
There are two problems with it. One problem is a closed finite, a closed space-time of 0 radius, is that really nothing? Well, there's no space and there's no time, so anything that exists in space-time can't be a part of it. But what about physical laws? What about mathematical entities? What about consciousness, value, all the things that are possibly non-spatial, non-temporal? Those aren't ruled out, so it seems to me that the
so what you're
notion of
saying-
nothingness is a very parochial
We'll get
one.
back. You raise
Yeah.
a really important point that I want to get back to. What you're saying is you could have a universe that's got nothing in it, but if laws of physics still apply in that universe, the laws of physics are not nothing.
Yeah, and where
We'll
are the
get
laws
there.
of
Okay,
physics?
Lawrence, you are saying that because we are illuminated by the actions of quantum physics mentally, we can think about whatever is our best understanding of nothing, and quantum physics then pops into existence in that nothing an entire universe. And if that's the case, I would then pick up Jim's point and ask
I was
you.
going to try and ask, where did the quantum physics come from?
No.
Is that what you're
That's
asking?
not what I'm going to ask you. I'm going to
Okay.
ask you, that had to happen at some point.
Why?
Why isn't it happening all the time,
It can
everywhere,
be.
at all times?
First of all, it can be, and it wouldn't be noticeable at all. Okay, it could be happening in our universe. You'd be popping off baby universes, but they would disappear from our universe.
Okay, why don't
wouldn't
you
see
like
them-
his nothing that he birthed
But,
his universe
but
in?
that's, okay.
Why don't you like his nothing? That sounded like a good
Well, first of
nothing.
all, as he himself admits, his nothing is a something.
Well,
when you start with a
what is the
contradiction, you can
something?
derive anything.
but
And when you start with a
What is the
contradiction, you can
something?
derive anything.
let me-